Hey, QED Coders, this is Michael. Jan is not going to be here today, but I'm leaving the Discord open, so if you want to join in, have a conversation, then go to immutablearchitecture.com and you can find the link to the Discord, and of course, watch the stream live on YouTube. And so today, I want to talk a little bit about images. You see, I really want to get some applications built, and one of the ways that there it is. One of the ways that I want to try building applications is to use some of these app kits here. So we've got the Grial. It looks like Grail, but the A and the I are backwards. They should have kept AI in there. But you can see all these different application templates. So many of them require images. They've got photos of vacation places, homes, people, but then also images such as icons. So you should be able to support images in your applications. And then this is the other kit that I want to try using, Maui Kit. And yeah, you can see their example applications are also very image-based, which makes a lot of sense. That is what makes a good-looking app. So in order to accomplish that, I need to add image support, but Janaga itself does not support images. So let's go to github.com/Janaga, and we can see all the various projects. So Janaga.net, the project that I'm using to build all my apps. This is all about facts, all about these JSON objects. So here's an employee, here's a company, here's just a small amount of things. If I want to put this image into a Janaga application, I wouldn't be able to just put it into a JSON object. I need to host it somewhere. And so in order to accomplish that, I have started this little repository right here, shared image. This is a sample project that uses blob storage and table storage in Azure in order to store images and their metadata. And it uses a technique called content-addressed storage in order to accomplish that. And so that's a useful technique that you can use in all of your stuff. And so I wanted to share that. I wanted to make sure that we had the opportunity to use content-addressed storage in all of our applications. Now, what is so awesome about content-addressed storage? Well, if you go to the wiki page, this will give you a nice demonstration or explanation of it. The basic idea is that you compute the hash of... doesn't have any images on it. Okay. Well, the basic idea is that you compute the hash of your image, the thing that you want to store, and then you make that hash its name. Why is that so cool? Well, if two people want to store the same image, or if you upload the same image twice, then it gets the same name, and you know that you've already got it. So think about all those photo management apps that you've got on your phone and on your PC, where it's like, oh, I've got this picture that I took over here. Do I already have it in my collection or not? I don't know. I'm just going to import it from my phone, and now you've got a copy. And then you have to tell the app to go through and change all those copies. And every single one of them has image 4579 as the name, just IMG. It's a worthless name. Replace it with another worthless name, but at least one that is unique for each image, and it's going to be the same if the image is the same. And that's content addressable storage. So that's what we're going to be doing here. Now, I could just walk you through this project that I built last night, or let's have some fun. let's build it again. The way that I'm going to build it again is I've got this ASP.NET application that I just started up. This is a brand new ASP.NET application. It's got your good old weather forecast controller in there. And so when I run it, then I get this. And I can hit the weather forecast, boom, get a random weather forecast. So I've got my Swagger page, got my endpoint. This is just what you get out of the box when you create a brand new ASP.NET web application. Now, there's a lot to building an image host, and I needed some help. So I enlisted the help of my good friend ChatGPT. Let's make sure that I get logged in and everything's set up over here. And I had a little conversation about what it is that I wanted to accomplish. And that gave me a nice little start. So, kind of kicking things off, I was testing out the reasoning capabilities, and I started it off in the 01 reasoning model that's currently in beta, and it came up with some pretty good recommendations, but also some pretty bad ones. So, in particular, it was talking about just accessing the blob storage container from the client. And I'm like, no, that's not the way that I want to do things. That would not allow me to implement the security rules that I want to implement. So how about we don't do that? And how about we set up an API to do that? So here's my concerns. Let's see if we can remove direct access to the blob. And here, the two of us together went even further and enforced access control for photo downloads. And that ended up in a place where it's like, no, that's too complicated for what I'm trying to accomplish right now. Let's take a step back. We'll revisit that idea in a little bit. And so I search for open source. Okay, let's relax these security requirements around retrieving photos. And then I got to a place that I really liked. So we can control the upload of photos, but then leave the retrieval as open. Why would we want to choose that particular security position? Well, let's talk about that. Now, when I'm hosting a set of images on behalf of a bunch of application users, I want to make sure that I can put checks in place. Make sure that the images are not, the service is not being abused. And so I want to keep track of who's uploading images, and I want to be able to deactivate people's accounts and rate limit and all those things around upload. And so I will need some sort of token in order to do that. But then for download, sometimes you just simply take the URL and you put it into a browser. So the browser is not going to give you back a JWT access token the same way that an application would. The browser is going to be using cookies. And so I want to be able to support the browser link and not have to go over to another server and exchange an access token for a cookie and then be able to access it. Maybe I'll get there, or maybe your use case is already there and you'll want to implement that feature. But for this one, let's leave that out. If you have the URL, you can get the photo. That's the idea. So this is a relatively middle of the road security position. If you have the URL, that means that somehow you've learned the hash of the photo that you want, which means you got it from some application, or somebody copied it out of the application and shared it with you. So it's not that somebody can just go and scan, give me a list of all the photos and just, rifle through everybody's data. There's still one extra step that you need to do in order to get that. So, shared links, they're a thing, but it's not the most secure thing. It's right there in the middle. And that's what I wanted to support for this application. All right, so once we established that and evaluated the security risks, then, I'm willing to accept these compromises. Let's update an implementation plan. So, here it's generating these shareable links with the SAS token. And I'm like, no, wait a minute. That still means that you are exposing the blob storage to the outside world, not what I want. And so, no, please, I don't want to expose that this is an Azure service. Let's do everything through the API. So, all right. Set the permission to public access off. And you can only access it through the API. And there you go. There's how you can grab an image from blob storage through the API and download it. Great. So we have what we need. Okay, so let's go ahead and get started with implementing this. Here is the post endpoint. So we're going to upload media using iForm file, and then we're going to validate to make sure that it is a correct media type. We're going to right here compute the hash of the image. This gives us our content addressed storage, and then upload that to blob storage and give you back a 201 created. So here are those functions that help us to compute the hash, to validate the media. So it's got to have one of these media types, and based on that media type, it's got to have one of these signatures at the beginning. So, hey, that's a really nice controller. Let's go ahead and grab that controller. So, that's going to be, what was the name of that controller? Oh, well, this is a controller action. This isn't even the controller. So I'm going to call it the image controller. There we go. So let's establish a route. We'll just call it image. We could use the square bracket controller thing, but that would give us the this capitalization. And I like everything to be lowercase. That's just me. Okay. Paste in the code that we have faithfully reviewed from ChatGPT. And we've got a few things that we need to add. So we need blob containers. So let's go ahead and add that dependency. Manage NuGet packages. And we want to install, it's going to be Azure Storage Blobs. Install that. And I accept. Okay, so now I can get a blob storage container, and we've got some HTTP headers that we need to bring in. Now we need SHA-256 in order to compute the hash. That's already in system security cryptography. So there we go. We've got code that compiles now. All right. Let's just build it and see if this works. I can guarantee it's not going to work, because scanning this, I see that it doesn't know my connection string or the name of the container. So that's clearly not going to work. But I want to see it fail. So let's run it. And let's see it fail. so I've got the web server going. Let's come back over here to Swagger, and I've got image upload. You know what? Modify things just a little bit. I don't actually want this to be image upload. I just want it to be a post to the image endpoint. Let's just change that right now. Build that. Okay, and now we've got just image over there. All right, so with Swagger, whenever you've got this iForm file, Swagger knows you need to choose a file from your machine in order to upload it. So we're going to do that. Let's go to the thumbnails and let's upload a thumbnail. Execute, and this is where we get our exception. Boom! So we don't have everything set up for the storage connection string, which is what we would expect. All right, and we can also see over here. Here is the console window showing us the same thing. So let's get that set up. All right, now to help me out with this, I'm going to enlist another AI assistant. So I did all of this conversation with ChatGPT 4.0 and 0.1 preview. And then now I'm going to switch over to a different model. We are going to use Claude. So I've got this open in Visual Studio Code. And here's Claude. Well, this is Claude Dev, a plugin for Visual Studio Code, and I give it my Anthropic API key. And now it's actually accessing Claude through the Anthropic API and using my account. So it just accumulates those nickels and dimes in my name. So far, I have spent 36 cents on various projects using this tool. It's well worth it. Okay, now for this, I want to add some context. So let's do @ and I'm going to say, let's add the well, I want to add the controllers, and I want to add the project file here, program.cs. Program.cs, yeah, there we go. So now I've added those to context. They can see those files. And now I want to say, please extract the blob container client from the controller. Yeah, image controller, that's the one. And use dependency injection. Dependency. There's an E in there somewhere. It's close enough. Injection to inject it. Configure the container client. App settings. JSON. Okay. And it also gives you a nice little running total of how much you spent on the API so far. So that little request right there so far has cost 3 cents in order to plan things out. So to accomplish the task, it is first going to, let's see if I can change the font. I can't really change the font. So it's first going to modify the image controller to use dependency injection. It's going to update program.cs in order to configure the blob container client and add Azure Storage connection string to app settings JSON. So Claude wants to read app settings JSON. I forgot to add that to the context, so now I approve it. And now it can read that. And then it adds Azure Storage. So that looks good. I'm going to save it. Boom. And next it's going to go out to probably the controller, right? Is it going to go to the controller next? Yeah, that is step 2. So come on, little Claude, you can do it. It might have gotten hung up. There we go. So we've updated app settings JSON. Now let's update the image controller. So we can see we've added the blob container client right here and created a constructor for it. It didn't like my comments. It stripped out my comments. You monster. Okay, well, we'll let it do that. It fixed some formatting. Thank you for that. And then, yeah, I stripped out some more comments. Why you strip out comments like that? Come on. But we've injected it. That's the whole point. So, you know what? Let's go ahead and take these comments and bring them back in. I liked them. There was a reason. Let's keep that formatting fix. Take that back, take that back, take that back. Yeah, take these back too. And that comment. Okay. Now this is the only change that I want to approve, not those other deletions. So save that. Now we are going to go to the program.cs and we're going to make some changes there. I can't believe that just a few years ago, I did not have GitHub Copilot or anything like this, and now this is just managing the whole project structure for me. Okay, so now we are removing the container client, and I don't know why I didn't do that all in one step, but yeah, so it's removing the constructor of the container client and using the one that was injected. Yes, that's precisely the reason I asked you to do that. And then it wants to read program.cs. I thought I already added it to the context, but sure, I'll give you access to that again. So far, we've spent a dime on this. And now we are going to configure Azure Blob Storage. So we're going to add Azure clients. There's an Azure Blob Storage client, and we're going to use the Azure Storage connection string in the configuration. And then, when we need to access the Blob container client, we will get one using the container name. So we've got the connection string and the container name. Let's see if that is right. It ended up doing things a different way in the other one. So, okay, we need to add something to the shared image project. What's it going to do? It's probably going to, well, I've already added the package. Maybe it's just checking to make sure that I've got the package installed. Yeah, thanks for providing context to the shared image CS project. I see that we've already added Azure Storage Blobs, but we're missing the ASP.NET configuration secrets package. Oh, look at that. Look at that. I had to do this in a separate step last time. Now it knows I want secrets. Okay, so let's add Microsoft Extensions Azure. Boom. And now that we've upgraded this with the necessary packages, we should be they should be resolved. And now let's look back at program.cs. Now I think what it's talking about here, we can probably go back and see, is it's talking about the red squiggly. But yeah, so now if we go back to program.cs, no more red squiggly. So that's the cool thing about Claude Dev. is that it is using the tools of the IDE. So that means it can access projects in your it can access files in your project. It can modify those files. It can add new files, and it can take a look at the build output. It can even run commands in the terminal with your permission. So it's got quite a lot going for it. Okay, so that's where we are. We have app settings JSON. We've got your connection string goes here. Your container name goes there. Cool. Now, I need to grab my connection string, and I'm just going to paste it right in here and check it in source control, right? Nah. Not going to do that. We're going to take one more step to make sure that this thing is secure. We are going to use user secrets. So we can see here that we have, for configuration, it's not setting up any specific configuration. So it's just using app settings JSON. So I want it to configure user secrets, and then we'll use those user secrets in order to override the Azure storage. Oh, wait a minute. But first, before we do that, a couple of things. Let's get this committed. I want to make sure that I commit everything except for these things. Let's go back to get ignore, and we don't want bin. We don't want obj. Save that. Now instead of 57, it's just 12 files. That looks about right. Initial commit. Should have done this when I first created the project, but this is fine. Next, let's go ahead and let's go to the controllers. Let's go ahead and get rid of this weather forecast controller. Don't need that. We can flip back to Visual Studio, or we can do all the work in Visual Studio Code. You know, I've gotten comfortable enough in Visual Studio Code, I can even do C# stuff there. It used to be just for my TypeScript stuff, but now when I run it, here I just have the image endpoint, and if I try that out, I'm still going to get an exception, but this time it's going to be that I can't create my storage connection string in this other thing, this other way of setting the connection string. So it says, nope, that's not a good connection string. Well, what do you want? You really think that your connection string is not a good connection string? Come on. Okay, well, let's get Claude's help on this. Next, I want to, first of all, let's take what Claude just did, and, oh, that's GitHub Copilot. We can still use Copilot for some things. I want to use Claude for this. So I've got this context of what Claude just did. Let's say, please write readme.md that describes to a new developer how to set up the Azure services we need. So it already knows what Azure services we need. Just create that README for me. All right, so far we spent 15 cents. And yeah, with just a little bit more coins in that bank, it's going to write all my documentation for me. You know, AI is good at solving complex problems, but not very good at solving hard problems. Writing documentation is a complex problem. It takes time. And you know what? If it produces good documentation, then what do we want to do here? It wants to read get ignore. Yeah, app settings JSON should not be committed to source control. No, 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 you're going off the rails now. Yeah, so it's got me a whole bunch of stuff, and then local settings JSON. That's not the way I want to do it. That is not the way I want to do it. I'm going to reject that, even though there was a bunch of other stuff in that get ignore that I might eventually want. You aren't going to need it till you need it. Okay. And it's... Wait a minute. I apologize for the confusion. Modifying get ignore is not desired. Let's take a different approach. Ensure this sensitive information is not committed to source control. Instead, we can create a separate app settings file for development. No, no, not what I want. No. Let's see. We'll update the README to explain how developers should handle app settings to keep sensitive information. You know what I want? What I want you to do? What I want you to do is this. Please configure user secrets to keep the sensitive user secrets are the way to go. So user secrets will take all of your sensitive information and keep it outside of the repository. It'll keep it just on your machine. So yeah, I apologize for you. Thanks for the guidance. You're welcome. So yeah, the hard problems are things like application architecture, things like making decisions about how to organize things. So I made the decision to use user secrets rather than have a separate app settings file that's just get ignored, because it's way too easy for somebody to stop get ignoring it and to accidentally check it in. It's still in the folder. So user secrets keeps that file in a completely different place. And user secrets really is a bad name for what the feature is. It's not for users, it's for developers. And these things aren't secret, they aren't encrypted, they're just kept off of the main, the repository folder. So they should be developer settings or something like that. And they can only be used in development. All right, so this is a better approach for managing sensitive data. Yes, I know. Well, that's the hard problem. Now, the complex problem is doing all the steps to make that happen. So we want to enable user secrets in the project file, update the README to explain how user secrets are used. Perfect. I was going to ask it to do that afterward anyway. And then modify the program CS file to use the user secret manager. So let's give it access to the CS proj so that it can add the reference to user secrets. So it added a user secrets ID. When I did this last night, it instead wrote the command line to do that, and I ran that command. But this one is fine, assuming that this is actually a unique GUID and not one that it pulled from memory somewhere. Even if it is one that it pulled from memory somewhere, if it doesn't collide with some other user secrets ID that I'm using, then we're good. All right, so now we want to use program.cs. And here it's going to add the use user secrets call so that it can configure it. Well, it didn't do anything like that. We don't need to make significant changes to program.cs file because Web Application Create Builder already includes user secrets in the configuration when running in development. Is that true? I don't know if that's true, but we're going to find out. All right, so let's update README. And this will give the other developers on this project instructions on how to set up their user secrets. So hopefully these instructions will tell it exactly where to find using user secrets for sensitive information, where to find the connection strings. So here it's telling it to init user secrets, which is what adds the GUID. That's the command line that it runs. And then your connection string here, your container name here, and you can list them out if you want to. Which, because you can list them back out, you can see them on the screen. That tells you they're not really secret. They're not encrypted at all. So, yep, that's good for configuring user secrets. Do we have instructions on how to get the connection string? So we've created the blob container. Get the connection string. Okay, it's right there. Perfect. All right, so then we'll save that. And now new users to the project will know how to set up their user secrets. Which means, hey, I need to set up my user secrets too. Okay, so it is finished. And then let's configure the blob storage through user secrets. Okay. Let's get that connection string, shall we? All right. So part of this I will do on screen, and then I'll drag it off to the other side to do the other part. In fact, let me go ahead and start off screen just in case something flashes. I think the Azure portal is set up well enough these days that it doesn't flash anything until you click a button, but I'm not entirely certain. Okay, so here is the MLP experimental resource group or storage account. So in here I've got security and networking and access keys, and here I know it doesn't flash. It has the keys hidden until I hit show. So I'm going to hit show. I'm going to copy this connection string, and then I am going to set that as a user secret. So it is copied. All right, we are back to hidden, and let's bring that back because it might be useful to see what's going on there. Okay, so we are here, and I want to set my connection string. So I will do that through the, well, if I do that through the terminal, yeah, I can do that. That's fine. I'll do that through the terminal. So here we are in PowerShell in the shared image project, and I'm going to use .NET user secrets set Azure storage connection string, and then I'm going to paste in my connection string. Close that quote, hit run, type in clear, and now it's been set. Okay, then I've got the connection string there. Let's go ahead and avoid hitting the up arrow, which will reveal my my user secrets. But then let's also set the container name. The container name, if I come back to storage, where is it? Containers. Here I've got a container name called shared image. So coming back here, we will do this part and set that to shared image. And boom, we have saved the setting to the secret store. Perfect. Now I could try this, but that would list it back out and you'd be able to see my connection string. It really wants me to reveal that to you, but I ain't gonna. All right. That goes away. And you can see here, it is not in source control. The shared secrets are in a completely separate area. And if you wanted to, you could right-click here and manage user secrets. I'm not going to click that because that would open up a JSON file that has those strings in it, and they're not encrypted. But you'll see that that JSON file is in a completely separate part of my operating system. Okay, now with all that, let's give it a run, and let's see if we can upload an image. Let me first show you that this shared image already contains 3 images that I have uploaded yesterday. And in fact, the Blob Explorer will render. Where did it go? Well, there's a download. I could download it. There it is. It will render that image. So here's here's a thumbnail for better model patterns, view model patterns that I uploaded before. Here's another one for just some clip art. Avoid async void. So I've got a few things already up there. So if I've got this running, then I should, right here, be able to upload another file. So let's do this one. And execute that. And this time, hey, we get a 201. So that means that it has successfully connected to the blob storage container and uploaded this image. And it gave me back a URL. The URL is yourapp.com/photo/ and then the hash. Well, this isn't yourapp.com. This is HTTP localhost 7021. So let's come over here, and this should be HTTPS localhost 1721. We don't care about Swagger index. And then now we're not using photo, we're using image. And that's where I want you to be able to retrieve the image. Now, so far we've just done the upload. Let's confirm that in fact it did upload. Come over here and close this. Now instead of those 3, we have 4. Here's the one that we just uploaded. And there it is. Oh, look, there's a bug. Yeah. All right. So, now we can upload media. Let's download that media. If we come back here to the plan that I was making with there we go. With ChatGPT, we came up with this particular endpoint for downloading from the Blob client. Okay, this was the SAS token version of it. Let's come on down to here's the upload using the table. Yeah, here's the download. But that's using the table. This is going on to the next step. So I don't quite want to go on to the next step. So what I want to do is use this nice little simple one. Yeah, that's the nice little simple one that I want. Just the hash and access control and optional expiration. Yeah, okay. We'll worry about that later. Let's use this to download. So there's upload media. I will rename this to download media. It just takes the hash, and rather than photo, we're going to use image, which is the controller's route. So we retrieve it from Azure Blob Storage. Well, we don't need to use that container client because we have one that we have injected. And we don't have hash.jpg, we just have hash. So do that. In fact, I'm not sure why it even did that much. This is fine. Just the hash, if you please. Okay, so get that client. Now, let's try this out. And we can see that it is trying to download it as image JPEG. I happen to know that these that I have tested with so far are PNGs. We will fix that later, but for right now, to see this work, we'll do PNGs. So let's let it run. And then when we come back here, we have the post and the get. So using the post, let's upload that file again. Now I hope that you memorized that hash, or you can just scrub back and you'll see that's the same hash as before. Same image leads to the same hash. But then this time I'm using localhost 7021/image/that hash, which is this other endpoint here. So that means if I go to that URL, boom, there's the image. It gets downloaded through that controller action. Excellent. Excellent. Now, what if I don't have that image? Then I don't get the behavior that I'm looking for. I get boom. There, is this the right one? Am I looking at the right one? It's not even logging the error. Why is it not logging the error? Come on, image, boom. Yeah, we can see this if we go over here, and let's run this guy. First of all, we'll run this using the actual hash, and we'll see it's able to download it. But now if we use something that's messed up, then, wait a minute, what? This doesn't make any sense. What is going on? Oh. Why didn't you tell me I did that? I just stored it with the name hash, and I was, oh, of course I've got a thing called hash. Yeah, right here. Refresh. There's a thing called hash right there. There's a bug. Okay. No, it's not literally hash. It's just the hash. Okay. Now let's give that a try. Come on over here. We will choose that file and execute it. And now I've got that file saved at this URL. And I can go to that URL and everything's good. And then I can type in a hash that doesn't exist, and boom, there we go. I get an unhandled exception. That's not what I want. I want not found, right? So let's do this. If it does not exist, return not found. Great. Thank you, Copilot. You read my mind. That was GitHub Copilot running in Visual Studio. It runs in Visual Studio as well as in Visual Studio Code. So now with this, now I get this page cannot be found. I get the proper 404. Okay. Same thing here. I use the actual hash. I get the actual image. I use the bad hash. I get a 404. That is what I want out of that. So let's commit those changes. Let's just double check the changes that I made. And yep, I am downloading the media based on the hash. Very good. Those are the changes that I want to make. There is another feature in GitHub Copilot in Visual Studio Code. There's a little button right here. Sometimes I give it a shot, but it always disappoints me. So refactor blob client in this instantiation in image controller. No, that's not what I was doing at all. Yeah, I was at an endpoint to download the image. There we go. All right. So, there are a couple of other features that that I really want to get to. Let's see how many of those we can actually get through. So yeah, you can see that here it is always assuming image PNG. So what I really want to do is to store the content type that I receive here in a table. When I planned it out with ChatGPT, we came up with this. So in fact, this is the one that I copied. So here, track the media type, and we can see we still have that comment for now because I told Claude not to delete it. Assume you're storing the media type along with the file. Eventually, I said, you know what? Let's go ahead and use Azure Table Storage for that. So we add the package Azure Data Tables. Let's go ahead and run that. There we go. We've got Azure Table Storage installed. Now we want to have a media entity. So let's go back here and let's create another folder. Add a folder called entities. And I want a class called media entity. And then let's go ahead and paste in that media entity. So got a few things that I like to do here. Let's go ahead and get rid of those green squigglies. And yeah, other stuff will happen there. So this is how we are going to store things in table storage. We'll have a partition key and a row key. Always need those things. So the partition key, in this case, it'll all be in one partition. We'll just call it media. And then the row key is going to be the hash. The content type will be the string, and then we'll have the time that it was uploaded. And this way we can keep track of other metadata around the images. So now that we've got that media entity, we will modify the post endpoint to store the metadata. So right here, this is where we are storing the media in blob storage. I copied the comment below because if I go back here to the image controller, Track the media type. Boom. Oh, that should have been step 4, step 5. Okay. Oh, well, no, that's right. We've already got it stored in media. Okay. I was off by 1 here. So, store it in table storage, and then we change this to step 5. There we go. So, stored in table storage by creating a media entity. The partition key is always media. The row key is the hash. Here we've got the content type, and now is the time that we've uploaded it. So here is my table client. You know what? I want to inject that too. Hey Claude, help me out here, will you? Let's start a new task so that we can just focus on this, and it doesn't have all that previous context cluttering things up. So please inject the table client into image controller. Modify the IOC configuration. And go. And then it will figure out what it needs access to, and it'll ask me for access. So it needs the image controller. So yep. We're going to read the contents of image controller, and we're also going to read the contents of program CS. Then we're going to make a plan. What is your plan, Mr. Claude? And can we get this plan accomplished in the next 2 minutes? Okay, so step 1. Inject the table client. And then, why do you want to undo? Oh, it's a duplicate. I introduced a copy-paste error, and it said, hey, that was an error. Let me go ahead and fix that for you. And now here, it is using that injected table client. Perfect. So not only should we be good reviewers of AI-generated code, but the AI can be good reviewers of our code too. All right, so now we add Azure Data Tables, configure blob and table storage. There we go. We've got our Azure Storage connection string. And then here we will use the Azure Storage table name to create our table clients. Very good. I like that. Let's keep it. And now that we have both of those, we need to ensure that app settings file contains the necessary configuration. So you may read the contents of app settings JSON. Yeah, I wonder if it's going to offer to update the README, since that was in another context that I asked for that. So, yep, let's go ahead and set that table name there. Yeah, it probably doesn't even know that the README exists. So I will give it access to README. Yeah, so it did all those things. Great. So let's give it access to README. Add file. I wonder why I can't see the README. It's right here. Oh, okay, it's inside of this file. Well, let me copy the relative path. And I'll just paste that. Whoops. All right, shared. Let's try that again. Copy the relative path, copy the relative path. Does that happen to you too? That, well, If that's not it, it'll find it. You copy something and it's not actually in the paste buffer. Okay, please update the README with instructions. All right. Do the README thing. Certainly. I want access to README. I just gave you access to README. I want it again. Okay. So now it's going to read the instructions that it wrote in a previous task, but that task is out of context now, so it doesn't know how it wrote it. But it can look at the README and it can see how it was written before, and it can be consistent. So stored images and table storage to manage metadata. Good. Now we're going to create an Azure table, and then it renumbers things. And then we're going to add the table name to secrets and renumber things. And information about the documentation. That is so nice. That is so nice. So nice that I didn't have to write that documentation myself. And it's good documentation. It will help somebody to understand things. You do have to verify that it was correct. There's no guarantee that something that just predicts the next word is going to give you the correct information, but it's doing a good job. Okay, so with that, we have now stored the metadata in table storage. And so here I want to retrieve that information. I think I already had that conversation here. Yeah, modified the get controller action. And so we copy that. And I'm going to replace that whole thing. Yeah, there we go. So now it's just get hash, and we called it download media. We've got the hash. Now we don't need to grab the table client like this because we've already got one right here. So now let's just inline that. Boom. Okay. So we get the entity from the media table, or with the media, what is that called? Partition key, and the hash row key. And then grab the content type. And now we're not loading it from the container client like that. We are loading it from this container client. And inline that. Download as stream, return as file. If anything throws request failed exception, so either one of these two fails, then it's going to be not found. Otherwise, return a generic error. Perfect. And now with this, I should be able to upload things of various media types. Okay, so let's go ahead here. This one was a PNG. Let's find one. Like here's the Jinaga logo. I've got this one. Well, this is as a PNG as well. Here's the JPEG. There we go. Let's grab that Jinaga logo JPEG. Execute that. And oh, I need to save my user secrets off. So for this one, let's go back to the README. Let's see what we have added here. Add the table name to user secrets. So it's going to be like this, except the table name that I want to use. we've already set up here. So here's my MOP experimental. Here are my tables. I've got a table called shared image metadata. So shared image metadata. And it's the same storage connection string. And so with that, I should be good to go. Oh, yeah, let's do the build over here. That's fine. Why not? Why are we doing this? No. Let's come over here and do the build. Okay. So now that we've got that built, we should be in a place where I can upload that JPEG, and it should be able to connect to table storage. Boom. Yes. And we've got our 201 response body. Here is our location, so I can just navigate to that location, and there is my JPEG. Don't believe it's a JPEG? What we can do is copy that URL or that hash and just test it here. And what we actually get back is a 200 with the response headers image JPEG, not PNG. And it was able to do that because shared image metadata has stuff in it. Let's go to the storage browser. Let's look at the tables. Here's the shared image metadata. And here are the various hashes that I've used. This last one was 841. There's 841. Today, image JPEG. There we go. There we go. So let's commit that. So with this, I now have use table storage to store image metadata. There we go. So again, if you want to play around with this, I have the repository from what I built last night, which also took roughly an hour, right here on github.com/janaga/shared image. And you can see the nice AI generated README file that tells you what to do to get things started. Or you can just go through these steps, build it yourself, because building things using AI to generate the code is a lot of fun. It handles those complex problems for you, lets you focus on the hard problems of application architecture. So using content or just storage is a great way to make sure that we don't have duplicate images, and we are using immutability within our applications. And now you can just take the URL or the hash and you can stick that right into effect, and now that that application has access to that image. All right, so we're going to be using this in order to build some applications in Maui. So stay tuned for that. I will see you next time. Thanks.